Hello students, welcome to my YouTube channel UPSU Technical Center. Today's subject is power electronics. Topic is control strategies. First question is control strategies for what? Actually, in my last class, we have discussed the step down chopper and we got a formula of V0 equal to, if I write V0 is equal to 1 V0 is equal to alpha of Vs, where V0 is the output voltage, Vs is the supply voltage, and alpha is equal to duty ratio duty cycle, where you can write alpha is equal to T on by T, where T on is the on time and T is the total time period. And we know T on is always less than T. Therefore, V0 is always less than Vs. So that's why it is also called step down chopper. This I have discussed in my previous lecture. Go through the previous lecture for clear description. So here there are three, there are two control strategies. One is called TRC and another is called CLC. TRC full form is this: time ratio control. CLC is current limit control. I will discuss next lecture. Here the name is time ratio control. That means here this ratio will be in between two times. So from the name it is very clear to that by changing this ratio we control the value of alpha. Now time ratio control, from the theory of time ratio control, there will be two provisions. We go to the formula T on by T. So here time ratio control, we can control T on, we can control T. When we control T on, that means you are not controlling T. When you are controlling T, suppose T on is fixed, then we can say controlling T, that means variable frequency. So here is one is called constant frequency. Constant frequency means we are not changing T, we are changing T on. Look at this picture, here T on is changing. Look at here, this is T on. If I write, this will be T on and this will be also T on and this will be T off and this will be T off and this will be T here and this will be T here also. So for this picture A, suppose this is figure 1 and this is figure 2. Okay, if I put the number, so for the case of constant frequency from figure 1, you see T on by T, if I write alpha 1 T on by T, look at here, T on is, say, T on equal to 1/4 of T. So we can say alpha 1 is equal to 1/4 of t divided by t. So that will be 1/4, or in percentage you can say 25%. So you get output voltage 25%. Now here from figure 2, alpha 2 is equal to, formula is constant T on by T, and say here T on is most of the part of T, say 3 by 4 of T. So alpha 2 is equal to 3 by 4 T by T is equal to 3 by 4 is equal to 75%. So here we get different output for this strategy. So from the constant strategy we get 25% output and also 75% output. As per your requirement you get your choice. Next one, in case of variable frequency, this is for constant frequency. Now for the B, this is also the case of time ratio control, but here variable frequency. So variable frequency here, suppose this is for figure 3 and this is for figure 4. So in between figure 3 and figure 4, look at here. Here T on is constant. This is T on. So this is T on and this is T off and this is T. Here it is T on, this is T off and this is T. So here T on is constant. For this picture T on equal to constant. Okay, so therefore if we consider alpha 3 is equal to T on by T, here alpha 4 is equal to T on by T. So from this picture T on is 1/4 of total T. So here T on is 1/4 of total T. So you get 1/4, that is 25% as before. But here from this picture T on is 3 by 4 of total T. So you get 3 by 4 of total T, that means 75%. So in case of T on constant you get also 25% output, 75% output as per our requirement. Okay, now this is for the variable frequency. And next two picture, if I consider this is figure 5 and this is figure 6. Okay, so here we consider for this both picture T off is constant. So this is T off, this is T on, this is T. So here this is T off, this is T on, this is T. So here for alpha 5, look at here, T on by T. So as per the diagram, T on and T off, how much is there? So here T on is 1/4 of T, so it also gives you 25%. I am not calculating it again because as you see the picture here, T on is for the total period T is 1/4 time, it will be 25% for an alpha 6. Here the formula is T on by T, and here you see in the picture for the total time period maximum portion is on, that will be 3 by 4 time of T, so you will get the 75% at the output. So in this way we'll get the output with respect to supply voltages. It may be 25% or 75% as per the diagram, it may be others. The so the percentage is not, it will not be the fixed, but we changing this we get variable output. So this is the total theory of control strategy. Now question is that between these two control strategies, which one is better? So this part is very important. So first of all, look at the first one. Okay. So here in case of time ratio control, for the time ratio control, we are changing the T on, and in time ratio control for the constant frequency, we are changing the T on. Okay, so that's why it is called pulse width modulation. So it is also called pulse width modulation because here the T is fixed but we are changing the on period. So on period means pulse. So this is also called pulse width modulation. And in case of variable frequency, we are changing the frequency, so it is also called frequency modulation. Frequency modulation, in short FM, it is PWM. Now question is which one is better? So as per the theory, so pulse width modulation is better. Pulse width modulation better, and detail I will discuss in another lecture, but for the compact question, for the control strategies for the time ratio control, which one is better? Pulse width modulation is better. Look at the picture. In case of pulse width modulation, we are changing the pulses. So when you are changing the pulses in between the constant frequency, that will not be affected. But when in case of frequency variation or the variable frequency cases, when you are changing the frequency level, suppose when we are increasing the frequency, so that will be effect in case of output. So we have to design a filter. Okay, so in case of frequency variation, we have to design proper filter for getting proper output. This is one of the disadvantage because it is quite difficult to design a filter. So this is the first disadvantage of variable frequency. So pulse width modulation is better. Next, here in case of pulse width frequency modulations, when we increase the frequency level, that frequency also interface with the communication systems. So this is the Second disadvantage of frequency modulation. And third, when we are varying the frequency, it may be high chances that the off time is much more. Here, here is off time is much more. So high chances the system may be turned off. Okay, so off period is more, which is undesirable. So frequency modulation is not good for us. Pulse width modulation is good. But there is a limitation of pulse width modulation. In case of pulse width modulation, we have to reduce the peon. So, but here we are not we cannot reduce peon tends to 0. It is not possible. So this is the limitation, that when we want to reduce the T-on, it is not possible. That is the low variation, that is the low time ratio, that is T1 by T. The low time ratio is not possible for the pulse width modulation. But low time ratio we get by varying the frequency variation. Because here, in case of variable frequency, we are increasing the denominator T on by T. So by changing the T, we get low time ratio control. So low time ratio control, that means low TRC is possible for the variable frequency. But in case of pulse width modulation, constant frequency cases, it is not possible. So this is the limitation of pulse width modulation. For these advantages and disadvantages, I will prepare another lecture, separate lecture. But for the compactness, what will be the theory of control strategy only for the TRC case, this lecture is sufficient for. Thank you very much. If this lecture is knowledgeable, profitable to you, and you gather some knowledges, okay, so you give a like and share to your friends. And those are new for this channel, subscribe this channel to get a daily update regarding the channels. Okay, thank you very much. Thank you very much to all of you for cooperating with me. Thank you.